Hello and welcome to Keep It Science. I'm Dr. Elizabeth Kugler, a biomedical image analyst and science communicator, the director of SEEKS, and your host of today's Keep It Science episode, Keep It Technology. Our guest today is Dr. Malte Wachsmuth, who is the managing director and head of product management and application support and service, as well as IP at Luxendo, which is part of the fluorescence microscopy business unit at the Bruker Nano Surface division. So firstly, huge thanks, Malte, for being here today. And maybe you can introduce yourself a little bit, what you do as a managing director, who you are, and what Luxendo is to our listeners.
Yes, first of all, thank you very much for having me. It's a great pleasure and quite exciting, my first podcast recording. Yes, maybe a couple of words about what I'm doing and who we are. Luxendo is now part of Bruker, the fluorescence microscopy unit of Bruker, hopefully well-known supplier of scientific instrumentation. And we are focused on light sheet microscopy, which is a fluorescence microscopy method optimized for long-term imaging of large objects. I think we will have some time to go into more detail on this a little later. We are part of Bruker and became part of Bruker in 2017. Already almost 7 years ago. So after being founded as a spin-off from EMBL, the European Molecular Biology Laboratory in Heidelberg, Germany, where we basically started based on IP, based on lab systems that had been developed and published at EMBL. Based on this, we at some point decided that it might be a good idea to found a company making use of this technology to commercialize light sheet microscopy, because there was more and more interest in somewhat different way of imaging biological samples. And this was basically end of 2015 that we founded Luxendo. This was founded out of EMBL with a team of Lars Hufnagel, then a group leader at EMBL, Jan Ellenberg, also a group leader and unit coordinator at EMBL, and with financial support of EMBL Venture Capital, EMBL Ventures, and Emblem, which is also the technology transfer company of EMBL that helped us effectively to get started from a more organizational and less technical point of view. We then started the business in Europe, and we managed to get a quite decent start, I would say, with at the time one product, our movie SPIM, which is still our workhorse product, and then quite fast we were looking for partners and came into contact with Bruker in the US. Bruker is located in the US, but also has a large number of operations in Europe, in Germany, and at the time, and this is still ongoing, Bruker invested a lot in the areas of fluorescence microscopy and everything related to bioscience, and there was interest in especially advanced technology. At the time, the fluorescence microscopy part of Bruker had already offered two-photon microscopy and super-resolution microscopy, and the idea that light sheet microscopy could be added to the portfolio was quite appealing to both sides, and this is why things materialized quite fast. And since then, I think we're quite happy with that. Bruker is really a very innovation-driven company, and it's really very important for everybody and at Bruker that we keep a fast pace of innovation, that we really keep up with cutting-edge developments in our field. Before that, I've been a staff scientist at EMBL in Heidelberg. On the one hand, working on supporting other groups to develop microscopy, instrumentation, and methods, and on the other hand, doing my own research, mostly focused on nuclear architecture of nuclear structure. Before joining EMBL, I was a group leader at the Pasteur Institute in Seoul, in South Korea, and coming from a postdoc position in at the University of Heidelberg at that time, almost 20 years ago. This was my first position where I basically started running a lab, started running a team, and being responsible for more than just myself. Before my postdoc, which was a quite short one, I spent some time with another microscopy manufacturer, with Leica. And so this was my first interaction with the commercial part of our business and with industry. And this is basically something that has been part of my life since I finished my PhD, is that really I work back and forth a little bit between academia and industry. And I think that is something that I still appreciate very much. And I don't regret at all that I've taken this sometimes maybe a little bit unusual path in science, going back and forth. Sometimes you look a little suspicious, but I think this is very, very beneficial to see more than one perspective on science. At the end, it's always about the science that we are dealing with, that we are working on, and for which we provide instrumentation.
Definitely. And I think it's great to hear that you were stepping back and forth between academia and industry. And also that obviously the spin-off from EMBL, you have a huge team behind you. But I think also, especially in the light sheet community, we know that light sheet imaging is really fast developing, especially in the last 10 years. We've seen so many different technologies come up, right? Like you need to be reactive to what's happening. And so you need to have this exchange between academia and industry to really make sense of all the kind of developments and also applications. So it was really good to hear from you, like a little bit about the back and forth between industry and academia. And you kind of talked about that there was demand for light sheet imaging. But maybe you can talk a little bit about what was kind of the step that really led to you saying, okay, now we found Luxendo and we step away and, really have this, everyone has a little bit of fear of founding something. So how did you overcome this? What was your kind of initial driver?
Yeah, to some extent, we felt a little bit of a push. I mean, the scientific community really asked for light sheet microscopy. And then commercial offerings things were a little slow, I would say, in the market. And there was more and more question, can you just build a microscope for us? I mean, really, we need something like that. That's exactly what we need for our science. And it's as flattering as this may be, of course, it's not sustainable when you do this out of a lab. And that's basically how Lars, our co-founders and really a main driver behind founding Luxendo, how he started it, and it really turned out it was just a little bit overwhelming to run a lab with a certain scientific agenda and at the same time support others on a level that usually is done by a company with a larger team for all the roles and functions. And this drove a little bit, basically pushed us really into this direction. And I think I have to be quite grateful to Lars and to Jan, because they also basically said, okay, you need to join us here on this endeavor. And we also got really amazing support from EMBL, from a technology transfer point of view. So the fact that we had access to the IP that formed the basis for Luxendo, and also the fact that they were very supportive and really provided a great infrastructure, and so that this was possible at all. Because of course, as scientists by training, you really don't have much experience on how to start a company and how to take over all these responsibilities and all these tasks. So in the beginning, it was also quite confusing. Sometimes I have to say, it was difficult to tell what is important and what is not important.
Which is great to hear. And I think it's also, like you say, it's sometimes difficult to know what is important and what is not important. But I think one thing that you already touched on is that obviously first you had, like you did build light sheets already or microscopes already, but obviously if you go from academia to industry, the whole kind of team dynamic changes. And so now what I would like to talk with you a little bit about is actually understanding your leadership style.
Yeah, how would I describe this? I think what I've always tried to do is to be somewhat empathetic, to understand what drives the people in the team. It's important to actually enable your team, because I typically, that's usually also my working hypothesis, that everybody is pretty motivated to do a job. And I think we have a cool job to offer, and just don't be in the way. Yeah, in the way. Just make sure people can do their job. Don't be in their way. Don't be an obstacle in the way. And that's already quite a big step to understand. It's also to step back at sometimes and say, okay, you do your thing, even though I might think I would do it in a different way, but hands off. And that's something I keep telling myself: hands off here. Don't get I don't know, sucked into every little detail. That's not easy. Very often do not manage, but that's I think an important thing to remember, that don't get too distracted from too many details.
The start, you try to be involved in everything, but the more the team grows, you really have to step away from it, and you have to just let people do what they're doing, and you focus on your own things. But obviously your leadership kind of responsibilities change as the team changes. So it's really good to hear that you also say the main thing is to be empathetic and to enable people in what they are doing. So kind of linking to this, what do you think makes a good leader?
What I'm trying to do, as I said, empathetic, supportive, make sure that things that you keep on track. And that's the other thing, in a way, that you, when you're running a team, when you're running a company, you have to make sure that you keep on track, that you meet your targets. At the end of the day, you have the responsibility that things keep going, and you basically can earn enough money to pay for salaries and all the activities and the operations. So I think that's really an important aspect. One should not overload this, because usually you are quite aware of this responsibility, and then you kind of automatically take care of this. On the other hand, I also would like to hold people responsible, right? I mean, if once you give away tasks, you have to make sure that you don't interfere too much, but also then make sure that things actually happen also in a reasonable way, so that things happen the way you think they need to happen. So in a way, it's also, that's the other part of it, that you also have to make sure people take responsibility of their tasks and also deliver in a way. And if this doesn't happen, you have to ask what's going on, what's preventing you from doing your thing here, doing your job, and make sure that you can do everything to enable people to actually execute or do that task.
I think that's all really lots of gold nuggets to talk about, like authenticity and keeping people accountable and keeping them on track. I've worked with you now for a while, I think about a year now, which is great. And I think especially authenticity and your empathy is something that really strikes a chord with me, because I'm always impressed by the fact not only how very quick and rational you make decisions, but also that you have a really good way to understand what motivates people and what drives them. And so you're very good at kind of understanding, how to understand what drives people, how to get them motivated, and how to, vocalize any misunderstandings and get them out of the way. So I think, there's obviously a lot of working to do, but do you think that your ability to be so understanding and quickly decisive is also because obviously you work now internationally, like in Europe, America, China, etc., and that also understanding different cultures has helped you with being so empathetic?
That's well possible. Yeah. So first of all, I have been working in intercultural and international environments for more than 20 years now. And that makes you, in a way, quite humble, and you really learn to understand different cultures and different approaches, different communication styles. And after overcoming, all these cultural hurdles and potential boundaries, then you will also see that at the end of the day, people are people. And people are very, very similar in their individual motivations and in their personal what they would like to achieve, goals. So that's what I learned, and that's at the end, when you manage to overcome cultural barriers, and it's all very, very comparable in a way. And it's depends quite a lot on the individual character, how people are, what their character is like. And I think this helps a lot to try to understand how people operate. And I think what I think that is, I'm as you mentioned, now thinking about this, I can probably take decisions fairly quick and then fairly reasonable. I mean, it's probably a good trade-off between being able to take quick decisions and being able to take at the same time fairly rational decisions. Might not be the best decision you can ever take when you think about something for a week, but sometimes you just have to be fast. And then if the damage is limited that you create with taking fast decisions, it's something I think I'm not too bad at.
Before we move on any further, we'll just have a quick word from one of our sponsors and friends, Under the Microscope.
In a world where the tiniest elements make the biggest impact, where curiosity leads to groundbreaking discoveries, it's time to delve deeper than ever before. Welcome to Under the Microscope, the podcast that zooms into the captivating world of materials and nanoscience. With each episode, you meet a scientist working in the field of materials or nanoscience. On Under the Microscope, the scientist candidly talks about their career journey, their favorite research experiment, and their 3 wishes to improve the world. Check out Under the Microscope on your favorite podcast app.
Welcome back. We're talking to Malte about his career as director at Bruker's Luxendo. Now that we have heard a bit more about you and who you are, Malte, as well as about your leadership style, we would love to talk with you about the role of innovation and technology at Bruker's Luxendo. First question that we have for you, Malte, is maybe you can talk a little bit about light sheet microscopy and what are the applications? Like, can you maybe mention one very common application and one very niche example so our listeners understand, kind of the scope?
Yeah, sure. I mean, light sheet microscopy, maybe in a word, is a fluorescence microscopy technique that uses typically 2 or more objective lenses instead of a single one. Something you may know that when looking at a sample with a microscope, you have an objective lens, and instead of using one, we are using one to illuminate the sample, a very thin sheet or section of the sample from one side, and then perpendicular to that, we are basically using another objective lens to observe this very plane. And then you can really image in 3 dimensions, especially large objects from a biological point of view. For example, embryos of Drosophila or zebrafish, typical model systems used in biology to understand embryonic development. And this also is then a classical application of light sheet microscopy. And this is how this also made it into modern biological or biomedical research. This was a paper from 2003 from the lab of Ernst Stelzer at EMBL, together with Jochen Wittbrod. And then a student in his lab, Jan Hüsken, basically had the idea of actually using 2 objective lenses instead of 1. And then they mounted in a quite smart way little zebrafish embryo inside a water chamber, and then looked at this from 2 sides and could observe the development of this little embryo over a very long period of time. And this is really probably this was really a seminal paper in the field, and is probably the signature application of light sheet microscopy. At the other hand, what you can also do with light sheet microscopy, and from a microscopy point of view, an entire zebrafish or Drosophila embryo is fairly big, because with more conventional microscopy methods, it's very difficult to image this in its entirety. So imaging an entire developing embryo over time has been at the time really quite a step forward. On the other hand, you can also image individual molecules. So we have a version of our light sheet microscope that you can use to really follow the diffusion of individual molecules with a method called fluorescence correlation spectroscopy, or FCS, that really allows to measure and also image the mobility of molecules, and based on this readout also the interaction of molecules on a on a molecular scale. You can, comparable to, for example, FRED, that is probably a more well-known method. You can really see, understand, and quantify the dynamics of molecules inside a living cell or even a living embryo. That's probably the other end of the scale that you can cover with light sheet microscopy. And nowadays, you can even look at entire mice that have been made transparent with so-called clearing methods. The scale of these samples really is in the range of up to 10 centimeters.
It's fascinating, though, that it's 20 years ago, like the paper. And the technology has come so far. Like we went to like 2 objectives, and now we kind of moved to, or we then moved to 4, and now we kind of moved back to single objective, right? Light sheet. It's interesting to see the kind of iterations of the different microscopes. You can really go from a few microns to studying a whole fish, which is, or like, for example, a zebrafish embryo head is about 400 micrometer wide, right? Which is huge in the field of microscopy if you think about the scales. And then you kind of even move further to millimeters when you look at the whole fish, and then you talk about centimeters when you talk about mice. So this whole kind of scale that you can cover with light sheet is just fascinating. It's probably not possible with any other technique, right?
Probably, right? I mean, there's not too many imaging methods that can cover such a broad range of scales. And as you say, 20 years ago, it's all started 20 years ago and still developing very dynamically, right? After 20 years after confocal microscopy came into an actual commercial application, let's say, didn't develop much further, but with light sheet microscopy, there's still a lot of innovation going on, a lot of new publications, also new companies showing up in the market. So it's also challenging from an innovation for us, and that's something that's important for us, that we really keep track of what's happening, what next developments are, so that we keep track of that and ideally also have an offering for what people need.
So how do you approach innovation with your team, and also like the team development? Because like you say, light sheet is a leading edge technology. So the technology itself evolves incredibly fast, but then also the samples change, and obviously kind of the science changes. So there's a lot of dynamic movement. So how do you stay competitive and develop your latest product, for example?
Yeah, that's a good question. So we on the one hand, we really try to keep track of what's going on in science to understand where, as you say, new samples, new ways to mount your samples, new methods to prepare samples. Clearing is probably a prime example, or expansion microscopy is another example where new ways to prepare samples really put new challenges on also the microscope and the imaging system. That's something we have to respond to. So we try to really drive it, or have the innovation process driven by the application, by what are people going to look at, what are the next applications, and we try to see how we can cover this with our existing portfolio, which is already quite broad, but also what would be alternative or new developments. I think as a Bruker has a very well working innovation process established. And this helped us a lot to kind of orchestrate this process a little bit more, that we really properly and quantitatively analyze the market and try to understand in a robust and reliable way what new developments are and how we can basically change, or how we can adjust to these developments, and what we can do to develop effectively new products.
Now, again, switching gears a little bit, we would love to hear, what is your favorite part of your work?
Interaction with users, with customers, I have to say. So I really like this, even though that's part of this don't do it, hands off area of my work. I every now and then have to do this. I really like to go to meet customers, to understand what they are doing, to also every now and then sit in front of a microscope and take some nice images. That's the part I really like. That's a major motivation. I understand that I can't do this all the time, but I think it's also helpful, or at least for me, to basically stay connected to what is going on.
But yeah, sitting in front of the microscope is the best thing ever. So yeah, I have to agree with this. This podcast is also listened to by a lot of people who maybe just be postgraduates or have just finished their PhD or maybe are postdocs. You know, if a scientist applies to you, they all have great qualifications and, you know, bring a lot to the table. But is there maybe one key tip that you could share when you're interviewing someone or for someone who is generally entering the workforce?
At the end, you have to understand the technology. I think that's quite important for us. That's also a question I always ask. Of course, especially if it's a position that is linked to technology in the areas of applications or development. I also like to see how well people can present what they have done before. So I like to ask about your bachelor's thesis, your master thesis, for example. And if people can summarize this very well in a few words, so that I can understand it, even though this might not be from my field, that's something I appreciate. And then being kind of open in communication and ask questions. I think that these are things I appreciate in an interview situation.
When you come from a PhD or like an academic background and you have never interviewed, it's obviously also really daunting. So the more often you do it, the more relaxed you get. And I think that's also something to consider, that when you have your first interview, you're obviously nervous, right? But that's
absolutely, yes. I remember that, yes.
Everyone, yes. Where do you see the industry going, especially like microscopy and like life sciences in general in like the next 5 years?
Well, it's going, I mean, things in general go 3D, I would say, which is good for us because that's what we can serve quite well. So things really go spatial, things go quantitative, and that has been the case for the last 10, 20 years already. Things like AI will make our life both easier, I think, but also more complicated. Because easier in a way that you can do more things that require probably more skills at the moment, but also in a way more complicated because you also have to implement it, right? And proof of concept and controls become more and more relevant when you go in technological directions like that. So from a more technical point of view, more in our field, things go at the same time smaller and larger. So we somehow have to accommodate to this. So as we already mentioned, entire mouse and things start to go beyond that. And on the other hand, being able to image really on a molecular level is also something I see coming more and more in the context of larger 3D objects, 3D tissues.
Yeah, there's definitely lots of different developments happening. I'm personally, obviously, the biggest fan of quantitative image analysis and 3D. But like in terms of AI, you very briefly touched on it, that it's obviously a very challenging. I think the problem is also that you touched on that you need a proof of principle and you need to validate. And I think a lot of companies obviously jump onto the AI bandwagon because AI at the moment is the go-to word. But I love that you say you have to be cautious about it and that you have to have this proof of principle and quantify and validate before you implement AI. So maybe you can talk a little bit more about, your general thought on AI and the challenges that it brings to the field.
Yeah, I'm certainly not an expert in AI, but what I think looking back a little bit, so people have been working on similar concepts for a while, right? So I remember neural networks, they were a thing in the 90s. Then machine learning, so it's to some extent it's comparable. Of course, the experts might just shake their heads and say, no. But in a way, there have been similar approaches around, and they of course develop with technology as well and get more powerful. And I think we may even see a change these days. But that is something that will probably be part of science and also everyday life in a couple of years from now. So therefore, we should try to make sure to benefit from this, to make basically also our user experience easier. Running a microscope is sometimes challenging, especially when it's a fairly complex one. It might help a lot to make the user experience much easier and much nicer, but also help a lot to be just much more, to set up much more powerful image analysis approaches and do things that with our fairly rationalistic and sometimes reductionist approach we may have missed so far. So I think I would probably help a lot to cover much better the complexity of the world we're looking at in biological research.
Yeah, there's definitely lots of change happening. And as you mentioned, the field is changing with like expansion microscopy, AI, etc., etc. So Malte, thank you so much for joining us today. It was so exciting to hear from you about, your industry insights, how to align a team, and read all the different factors that influence innovation and technology. And lastly, rounding it off with a little bit of like, where's the field going and AI. So thank you so much, Malte, for joining us today.
Thank you very much for having me. It was a great pleasure.
Thank you for listening to our episode Keep It Technology, where we discuss the challenges of transitioning between academia and industry, how to align a team, and what factors influence innovation in technology. Our next episode will be Keep It Cycle. So as always, please follow us on social media, leave reviews, and share your thoughts and questions. You can find our podcast on Google, Spotify, Apple, YouTube, or whatever you're listening to this right now.
This episode was sponsored by Bruker's Luxendo, the light sheet division of Bruker. Bruker's Luxendo is the leading provider of advanced light sheet fluorescence microscopy solutions, including life and cleared imaging, long-term observations, quantitative imaging, as well as image manipulation. Luxendo's cutting-edge technologies empower researchers with high-performance imaging tools, driving innovation in life science and biomedical research. You can learn more at www.bruker.com. Thanks for listening.
Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
They make the sound by vigorously rubbing their penis on their abdomen.
Oh, yeah. Oh, my gosh. Then at night, they come out and crawl around your face and mate with each other.
Oh.
But
Victoria,
get this.
I would like to sleep tonight. As naturalists, let's face it, we find something dead, we go and we poke it with a stick. I did that with the deer like 3 weeks ago.
As you do. Rachel, no. You weren't paying attention. Blood and mucus.
Oh, right. Sorry.
All right, this episode is going off the rails.
This is the quality content people come here for.
Strange by Nature podcast was chosen as one of the best science podcasts of 2021. Come join the fun wherever you find your podcasts.